Dear students, good morning to all. Hope you are doing well. Today's our offline class is about cardiac cycle. The cardiac cycle refers to the repeating pattern of contraction and relaxation of the heart. The phase of contraction is called systole and the phase of relaxation is called diastole. How does the heart function? Let us take a look. To begin with, all the four chambers of heart are in a relaxed state. That is, they are in joint diastole. Blood from pulmonary veins and vena cava fills the left and right atria respectively. The build up of pressure that results causes the AV valves to open and blood to flow from atria to the ventricles. At this stage, the semilunar valves are closed. The SAN now generates an action potential which stimulates both the atria to undergo a simultaneous contraction known as atrial systole. It results in increase of blood flow into the ventricles by about 30%. The action potential generated by the SAN is conducted to the ventricular side by the AVN and AV bundle from where the bundle of his transmits it through the entire ventricular musculature. This causes contraction of the ventricular muscles known as ventricular systole. The atria now undergo a relaxation called as atrial diastole, which coincides with ventricular systole. As the ventricles begin their contraction, the intraventricular pressure rises, causing the closure of tricuspid and bicuspid valves, that is AV valves, due to attempted backflow of blood into the atria. When the pressure in the left and right ventricles becomes greater than the pressure in aorta and pulmonary artery, respectively, the semilunar valves are forced open. Opening of semilunar valves guarding the pulmonary artery right side and the aorta left side allow the blood in ventricles to flow through these vessels into circulatory pathways. Now the ventricles relax, that is, ventricular diastole occurs and the ventricular pressure falls, causing the closure of semilunar valves. It prevents the backflow of blood into the ventricles. The ventricular pressure declines further and the AV valves are pushed open due to the pressure in the atria exerted by the blood which was being emptied into them by the veins. Once again, the blood moves freely into the ventricles. The ventricles and atria are again in joint diastole, that is relaxed state as earlier. Soon a new action potential is generated by SAN and the events described above are repeated in that sequence and the process continues. This sequential event, which is cyclically repeated in the heart, constitutes the cardiac cycle, which consists of systole and diastole of both the atria and ventricles. Our heart beats 72 times per minute, that is 72 cardiac cycles are performed per minute. Now, if 72 cardiac cycles are performed in 60 seconds, that is 1 minute, then one cardiac cycle would occur in 0.8 seconds. During a cardiac cycle, each ventricle pumps out approximately 70 ml of blood. This is called the stroke volume. The stroke volume multiplied by the number of beats per minute, that is heart rate, gives the cardiac output. The cardiac output is 72 into 70 or 5040 ml per minute, that is about 5 liters per minute. Therefore, the volume of blood pumped out by each ventricle per minute is known as the cardiac output. The body is able to alter the stroke volume as well as the heart rate and thereby the cardiac output. As for example, the cardiac output of an athlete will be much higher than that of an ordinary man. During exercise, the cardiac output can increase up to 5 folds from about 5 liter per minute to about 25 liter per minute. This is primarily due to an increase in heart rate, which increases the blood flow to skeletal muscles. The heart rate can, however, increase only up to a maximum value, which is determined mainly by a person's age. In well-trained athletes, the stroke volume can also increase significantly, allowing these individuals to achieve cardiac outputs during strenuous exercise up to 6 to 7 times greater than their resting values. This high cardiac output results in increased oxygen delivery to the exercising muscles. This is the major reason for the much higher than average maximal oxygen uptake of elite athletes. Thanks.